Okay, so the next question that we're going to talk about and review a little bit is box plots. The first thing you're going to do is find the mean, median, mode, range, minimum, maximum, first quartile, third quartile, and interquartile range of the following data. Label any outliers. If necessary, round any results to the nearest tenth. Okay, so let's start with this. Let's start with you finding the mean, the median, and the mode. Remember, always stop and start when I pause. Okay, so the mean is 47. You just add them up and divide by how many there are. The median is 36. How do I know that? Because there's a total of 3, 6, 9, 12, 14 scores. Since it's an even number of scores, there'll always be 2 scores in the middle. So I look for those middle 2 scores. If it's 14, those middle scores will be the 7th and the 8th. I make note of them, pay attention to them, circle them, whatever you want to say, and I take the average of those 2 scores. The average of 35 and 37 is 36. So you could look at it as what's the middle of 35 and 37? 36 clearly, or add them up and divide by 2. If you add them up, you get 72 divided by 2 is 36. Finally, the mode. The mode is the most frequent or the most popular. 33 is it. Maximum and minimum we'll talk about a little bit later. Okay, so the next thing we need to do is we need to find the first quartile, the third quartile, and the interquartile range. And then we need to talk a little bit about minimums, maximums, outliers, and the like. So why don't you, right now, try to find the first quartile, the third quartile, the interquartile range, and any outliers, and also if there's a minimum or a maximum, label those, okay? Go ahead, a little stop and start, and then we'll put it up. Okay, so the first quartile is 32. How did I get 32 for the first quartile? Well, the first quartile is the median of the first half of the numbers. So there's 7 numbers in the beginning of this. The middle term will be the 4th term, right? If I do 7 divided by 2, I get 3.5. So the 4th term is the middle. 3 below the 4th term, 3 above the 4th term, out of the 7 in the 4th term itself. So 32 is the first quartile. That's the middle of the left-hand set. Now we need to do the right-hand set of numbers to get the third quartile. I underline the right-hand set, and what I find out here is that the middle term is 51. It's the guy that's in the middle there. So we would say that 51 is the median. All right. The next step up is to say, well, what do we think is, or the potential for any outliers are? I'm actually, there's a little bit of a hitch in that, but we'll talk a little bit later about that and clean it up. The interquartile range is the third quartile minus the first quartile, which is 51 minus 32 is 19. Now, as far as identifying outliers go, it's going to be 1.5 times the interquartile range. So if the interquartile range is 19, 1.5 times 19 is 28.5. So what that means is when I look for outliers, I see if there's anything way too small. So I take the first quartile, which is 32, I subtract the 28.5, and I get 3.5. None of these scores are smaller than 3.5, so there are no outliers. Likewise, for the right-hand side, I want to see if anything is bigger than the third quartile plus 1.5 times the interquartile range, which is 51 plus 28.5, which is 79.5. Is there a number greater than that? Yes, there is. There's 179, which is an outlier. When there is an outlier like 179, then what we say is that the maximum has to be, or it can't be an outlier. So the maximum is 61. The minimum is 8 because there's no outlier on the small end of things. Okay? Now we take all of that data and we draw a box plot. So there's the number line. And notice everything is kind of pretty much laid out evenly. A nice scale to it. Now here's my box plot. First, notice the outlier, the 179 all the way out there. Then notice I have my minimum at 8. I have my first quartile at 32. Hush, Siva. I have my median at 36. Sorry about the dogs going nuts. I have the third quartile at 51, and I have my new max at 61. So there are all of my values labeled, and I would make it a point to label it on your box plot so there's no doubt what you intend. Okay? All right, so that's how we go over a box plot. Now let's take a look at some vocabulary-based questions. We'll stop and start here. Okay. Number 1, researcher uses an anonymous survey to investigate the study habits of American college students. Remember, there are many students in America who are going to college. Based on a set of 51 surveys that were completed and returned, the researcher finds that the students spend an average of 4.5 hours each week. For this study, the average of 4.5 hours is an example of, well, look, the real question here is the 51 surveys that were returned, is that every person in the entire population, or is that just a sample of the population, a part of the population, a smaller piece of the population? And the answer is clearly there's a lot more than 51 people who are going to college in the United States. So therefore, it is a statistics. Remember PPSS? From a population, you draw a parameter. From a sample, you draw a statistic. So this is a statistic that's drawn from a sample of 51 people, or 51 surveys. Number 2, researchers interested in the eating behavior of rats and selects a group of 25 rats to be tested in a research study. The group of 25 rats is an example of, and that's a sample because that's a group of 25 out of all of the rats that they had in their particular place. Okay, and you know that because it says selects a group. So that means that he didn't take all of them. Okay, or she. Number 3. Although a research study is typically conducted with a relatively small group of participants known as a most researchers hope to generalize their results to a much larger group known as a The small group is always known as the sample, and then you want to take those results and generalize them to everybody, and everybody is the population. So it's choice A, sample and then population. Okay, so here are another group of questions to get done. Finish these, stop and start, and put them up. First one, statistical methods that organize, summarize, or simplify data are called descriptive statistics. All you're doing is describing the statistics. Inferential statistics would be times when you took the statistics and applied them to larger groups. When you're simplifying the data that's there, you're just showing, you're taking the whole group and simplifying the stats for everybody to see from. Okay, next, which of the following is an example of a discrete variable? And that one is, and I got to tell you something, these drive me crazy. Absolutely crazy. I almost didn't want to teach the class because of how much these drive me crazy. If you go on some websites and in some textbooks, it'll tell you that gender is never a discrete variable. Yet, the answer to this one is gender. And that's because they give it like a value of 1 if a boy, 2 if a girl. What you can say here is discrete, you either have a value that's indivisible. It can't be broken down anymore. Weight, time can always be broken down, and age, it can be broken down by days, and we never do that. So sometimes I tend to think, it could be age, and some sources say it's never gender. So as much as I don't really like age as an answer, because some sources say it's never gender, I'm going to go with age, and I went back and forth on this. But ultimately, in referencing the source of the question, the answer they gave is gender. So that's really the best example, the best explanation I can give to you. I can't give you a better explanation except to say that any website that says gender is not a discrete variable is simply wrong. And I think the reason for that is because they're not allowing for the fact that you can assign a number to male and a number to female, 1 and 2. Okay. And age, while we don't usually walk around and say, well, I'm 17 years, 247 days, 31 minutes, and 10 seconds old. you could do that if you wanted to. And because it can be further broken down and be divisible, we don't want to call age a discrete variable. So I think this is one of those, like, the best choice, not necessarily the perfect choice, but the best choice. But these really do drive me crazy. Next, which of the following is an example of a continuous variable? And that's where you can break things down. Discrete, you can't. This, you can. So time is something that you can break down further. We just talked about gender, the number of males in each class. You can't have a part of a male, and you certainly can't have like 2.5 kids in a family. So therefore, the amount of time is the one that is a continuous variable. All right, the last thing that we're going to talk about here in terms of our review of the past and the warm-up on what we've been working on is stem and leaf plots. So Zach Wilson is the rookie quarterback for the New York Jets. His first 12 starts, he completes the following number of passes. That would be really nice if he can do that. Plot them all down, make yourself a stem and leaf plot. Go ahead. Okay, so there's your answer. Remember, 1/7, a stem of 1 and a branch of 7, or a leaf of 7 is 17. A stem of 1 and a leaf of 9 is 19. 2 0 is 20, and so on and so forth. From here, it's pretty easy to see certain things. For instance, when you look at the chart, you can see exactly what the mode is. There's actually 2 modes here, 25 and 33. It is possible to have 2 modes. The minimum and maximum are easy, 17 and 41. That is, of course, assuming no outliers. And last but not least, the median you can tell by the middle term. There's a total of 12 here. So if I go 2, 4, 6, and if I go down from the top 6 places, I end up, because there's 12 scores, with these 2 in the middle, 5 and 7, and the average of 5 and 7 is 6. So we would say that the median is 6. So that's organizing data according to a stem and leaf plot. In a moment, we'll start some new material where we start focusing on mean and median.